Well, good evening, everyone. Oh, is my microphone too hot? Well, let's see. Let's first turn down the music a little bit. We are very much into the... I'm clipping. Okay, hold on. Why? There. We are very much into the pre-stream here. A little bit more. There. Good evening, and how are you guys doing tonight? Let's see who's already here. Oh, it doesn't want to scroll for me. Tomas Orzekowski, he's wondering, he would love to watch the live stream. He's about to experience the same thing with my app, with my NetApp disk array power supplies. Oh, I've modified some disk arrays themselves. I guess also the power supplies with Noctuas too. You have to keep watch that the disks will still get properly cooled, but other than that, Digital.Tech. He's what to put hovercraft fans on the 2000 watt power supply. No, it came with hovercraft fans, so we're going to replace those with Noctuas. Yes, and okay. Greg E got the RD6030 also, the benchtop power supply part, with the 1500 watt external PSU. Yeah, I don't know. I didn't like their offering. I've had some of them before, so I thought, let's buy a different one. That's why I got the different power supply. Let me see if everything is running correctly. Are we 60 FPSing? Yes. Very good. Okay, very good. Greg Cressy says, "Hi Quindor, greetings from Scrunthorpe in the UK, from the Cressys." Okay, at some point can you do more in depth about user mods using GitHub online site where you just download after telling what mod? Well, I'm used to custom compiling them, so I don't know. I know there's a bot on the WLED Discord. Maybe you can use that. Philip is here and Johnny is here. What kind of shield are we talking about there, Philip? No stupid spanners. Okay. Well, since we're in the pre-show, I guess we got to do the drinks. And tonight is the night. Hold on. I need to rearrange my desk here a little bit. There. Tonight is the night of Fanta Zero Sugar with pineapple grapefruit. Okay. And we have some Pepsi Zero Sugar. I thought we had a flavor, but this one doesn't, it seems. What? What? Pepsi? Yes. So we'll need to make that an ultra, because, you know, ultra makes things taste better. So let's see if we can design a nice ultra. Oh, the 2000 watt was out of stock when you tried to order it. I did the influencer thing. I don't know. Ultra. Okay, so then this is now the Ultra 2000. More. Let's see, different font. We want some kind of stupid font. Hold on. I'm designing a label. Okay, and then we want high quality. Go. Sometimes the print... Oh, okay. Sometimes the printer doesn't work after a really long time, but this time it did. Okay, we've got our Ultra 2000 label. So now we can make some Pepsi Zero Sugar Ultra 2000. It's not maximum taste. It's Ultra 2000. There. Much better. I don't know. Is the link in the description not working? Let me check. Get in there. Let me check my own video description. We're in the pre-show anyway, so edit. 2000 watt power supply. Go. Oh, yeah, it's sold out. It's no longer available, it says. What? Why? Okay, let's go to the store, see if they have a new listing. Let's search for 2000 watt. Nope, only the 1000 watt. Interesting. Well, I guess I better not break it, because I can't buy a new one. Funny. Cancel. Yeah, you're here in time, Alex Morbo. Jacco Wies is here. You missed the start. You had only the second thumbs up. What is going on? What are you people doing? Why is there crap on my desk? There. I have moved the crap from my desk to the ground. That's called cleaning up, right? Okay, let's get into my Ultra 2000 drink here, because it has to be good, right? No, I know listings can sometimes differ between like Europe or even the Netherlands and Germany can differ. But especially like US or Australia or other parts of the world. But this one seems to be sold out for real right now, so I don't know. Maybe Alex, it could have been, but it was a long time ago then. Ooh, 2 epics, nice. 250 terabytes, whoa. Oh, Greg asks, what I meant, Quindor, if I download it and make a mess, how do I go back to the way you sent it with the latest WLED install? You go to HTTPS install.w. Jesus, my words are not working today. HTTPS install.quinled.info, and you plug it in USB, and you can just flash whatever firmware it came with, or well, the most updated one we deliver. Oh, MSX Droid is here. Hey guys from Hungary, Slizard. Silard Cos. Okay, I'm gonna try and stop pronouncing these names. It's never gonna work. This is your state by the end of the week. Forgetting words, letters, and phrases. Well, I just need to get into it. I haven't talked a lot today. I don't know. I didn't get a lot of sleep. Maybe that's it. We'll see. It should be fine. We're just doing some fun projects today. Although, I guess we should try not to touch the AC capacitors in there. Never ever will happen to say my name correctly. I agree. 5 days with 6 hours of meetings. What? You don't get any work done at all. Wow. Maybe that little zap would restore your ability to read and speak. Hey. Who knows? Well, let's slowly get started. because we want to do two things today. We want to modify the power supply, and we're going to use two of the Noctua A6 X25 FLX fans, and those are 60mm fans, and they have something called, and this is really interesting, it's like we're on Star Trek. They have a smooth commutation drive. They have a smooth commutation drive too. What? Is that like a sort of experimental warp drive? What does it do? So yeah, SSO2 bearings, and it has a cool frame and blah blah blah. Well, let's look inside. Oh, it's a tiny, cutesy little fan. So yeah, let's get these out. Oh, we got some accessories. It comes with a standard 3-pin, so it's not PWM, but as we saw last time in the power supply, it doesn't really supply PWM. We've got a Molex adapter, and we've got some low noise adapters. So this is a low noise adapter, but this is also a low noise adapter. And since it's a 3-pin, it doesn't do PWM, so it has to do this by lowering the voltage, I think. We got some of those rubber plugs to install it. Probably won't use those. I think we can reuse the original screws. So let's keep the accessories for what they are right now. We're just going to use the fan. Noctua costs as much as a Boeing. Yeah, well, I didn't want to cheap out. If they would have had a Redux version, I probably would have bought the Redux version. Basically, it's just almost the same fan. It just doesn't come with all the accessories, which we're not going to really need. But yeah, I don't think they make a Redux for the 60mm. So, okay, let's get the power supply on the desk. There is our giant power supply. Let's disconnect it from AC. I tried to drain the, the capacitors by trying to turn it on and stuff like that. So in theory, those are drained, but in practice, you never know. So we're going to be somewhat careful with that. Oh, I've already dinged it up. Okay, let's start by removing the screws and see what we need to do. Short the AC pin. I'm pretty sure it's going to be empty because I saw the voltage drain out of it, but I'm just not going to touch it. So, I showed you my drink. What are you guys drinking? Yeah, I guess that's true, Philip, but I guess I could measure the AC pins. That would be interesting. Let me do that. Let me start up the measurement software. I actually recently found some different measurement software, but we're going to use the same as we always have. There. We have measurement. And I guess we should set it to AC then. AC voltage. Oh, I need to do it on the screen now. Let's see. AC voltage. There. Okay, where's the plug? So let's measure the two. How do I do that without? Okay. No, I don't think there's much on there. I'm measuring as best I can. I can do it the other way around. No. all dead. I can measure it with ground. Or earth, actually. No, that seems pretty dead. So that's good. You see, some messages are not on your screen. Same issue someone had here a while ago. Yeah, I don't know what that is. I'm not sure what I can do about that. Right now, not that much. So this comes off. And we've got our little power supply here. I want to touch this capacitor. This capacitor's like bent down. I immediately want to touch it to bend it back. But I'm not gonna. I'm gonna try and not touch it. Coke Zero Tropical is out of stock. So just the ordinary one. Okay. So this is the fans we want to replace. And oh, it seems it's hooked up with 2 pins twice. So I'm thinking we're going to snip off the wires and then just solder it onto the new fans. But I'm not sure yet. Let's remove these first. Is there pink Noctua fans? No, they fought for years to, you know, only get black Noctua fans, let alone pink. So this power supply has been on basically the whole week. I've been testing the RD6030 and attached things I wanted to test, including long time testing, and it's been doing great. Also, ripple-wise with the scope, it seems fine. So it seems that, well, this 2000 watt supply is giving off clean power. You need to create a PWM board for the fans, otherwise it will be boring. Yeah, well, I could, but that's kind of out of the scope of this video. At some point, I do want to create a Quinn fan. I have plans for that. I've already worked out schematics like years back, but I never got to it. So, I haven't been a fan of alcohol or beer, partly because of diabetic, I guess, but mostly because I don't like the taste of alcohol. The taste of alcohol, if it's in something, is so overwhelming for me that it's basically 99% alcohol and then there's some hint of flavor somewhere. Where others will say, oh, we almost can't taste the alcohol at all. And I'm like, that is the only thing I taste. And I don't like the taste. So anything that has alcohol tastes horrible to me because I just taste the alcohol, which I don't like. So that's the main reason I don't drink. But I think it differs per human. Like some are just more perceptive, or I don't know, their taste buds react more to the alcohol than others. So that's why it's so different. So let's try and get these plugs out. There, that's one. And that's two. They're not glued down, so that's good. Okay, so now this is, okay. Well, okay, we need to see if the new fans will fit. The old fans were, how were they installed again? Didn't pay attention. I think they were installed like this. Yes, they were blowing. They actually have labels on here. That's fancy, schmancy. See, they have a little label on there. They were blowing air to this side, to the connector side. So the Noctuas also have labels on there. There. And let's see if they fit. Do they line up with the screw holes? They do. Very good. Okay. So these were Magao. Okay. DC625SH12. 0.2 amps. How many amps are the Noctuas? The Noctuas are, let me see if I can show you there. Well, now I can't see myself. 0.08. So they're about half the amps. Let's hope they are double the efficiency. And then, well, you know. Need some high-speed Delta fans. Well, no, these were pretty fast already, so I don't think that's needed. Now, is there a smart way we can do this? Why would they have 2 fan headers? I don't know. So, I guess this can go in here. This can go like that. But now we just need a way to be able to hook it up to those fan headers. Actually, we might get away without doing any cable splicing and or soldering. No, maybe not. Yeah, I don't have any 2-pin sockets or plugs. I also don't know what plug this is. Probably some standard plug, but I think I'm going to snip those off, and then we could maybe just Wago them and then stuff the Wagos in here, because we have these kits which also come with an extension cable, or we could take the Molex adapter. Yeah, let's do that. We can take the Molex adapter. No, these are 60mm. We can take both Molex adapters. We just snip off the Molex part, and then we snip off this wire from the fan part, and then we can connect that together, because this connects in here, and then this will connect to the original fan wire, like so, and that then connects into the board. And we can hide the wires here on the side. That's fine. Yeah, I think that's what we're going to do. That way we don't even have to solder. Wow. Now would be a great time to insert an ad. Well, no, I disagree. If one fails doesn't influence the other. Yeah, I guess. Okay, let's do the plan. I was thinking I had to solder, but if I don't have to solder, that's even easier. So I'm just gonna take some wire snips. Do we want a long? Yeah, we want a long wire. Okay. There. It will be short stream. Well, that's why we're doing 2 things today. We're also going to take a look at seeing if we can use an AC measurement plug we then add into Home Assistant for some real-time screen overlay goodness. Let's remove this. Yeah, I only need this part. I need to strip this back a bit. Might need to cut some of this tubing off. Let's do that. Okay. Try not to cut the wires. Wow. Stronger than you think. Uh-oh. It jumped into the power supply. Okay, got it. Okay, so this is good. We can put some wire ferrules on there maybe. We'll determine length later. Let's also prepare this one. Okay. And then there were 2. Right. So, if we're gonna take this, let's mark it up, right? We need to mark it up a little bit. Let me add 1 screw to each fan. I'm reusing the original fan screws. Those seem to fit fine. Something like that. Can we fit a Wago in there? Let's see. Not really. Oh. Okay, not this type at least. Let's see if we can do another type. No, maybe this type will fit. Okay, we need 2, and these join together. There. Not like that. Kind of fits. Oh! Say hi to Malachi. He's been begging you to ask. Oh no. I need my pliers. Where did I put them? There. Maybe the Wago thing isn't the best solution. I don't know. Don't we have some smaller Wagos? I know what we need. Yeah, hold on. Let me try and find those. Let's see if these might work better. These might be lower profile. And otherwise we can always solder them. But yeah. The 3rd pin on the standard fan connector is the taco pin, so that gives back the RPM the fan is spinning. Yeah, true. If we connect 2 Wagos, it would probably work too. Or if we disconnect them. But these fit a lot better. So let's just use these. Right. Okay. We shall use this copy Wago. And, well, these need to go into the corner and then get stuffed down there. And then from the Wago, they need to go back to the fan connector. So I probably need to keep this as long as possible. So we're going to snip it off right at the start of the fan. That also gives us a bit of, oh, we can Can we take the wire out and get more wire? Yeah. There. We can snip it off right here. Well, this fan's done for. Just change the pin out of the 3-pin connector and connect it to the 2-pin connector on the board. What do you mean? Those are two different connectors. This one doesn't have the same type of pins, I think. Okay. It's okay. We'll get there. Right. So we just need to join this together, and then the same for the other one. Yeah, Taco speed sensor. Yeah. Okay. So let's strip this wire. What? So thin. Now the question, of course, is, do we put... Now, I don't want to cut the Noctuas. That's the thing. Do we put a ferrule on there or not? Oh, we can just take this off. Good. I think we should. You know, then we should... We at least did something fancy during the stream. So let's get the ferrules out. We might have to double it up though, because these are really tiny. So let's see if these orange ones work okay in these Wagos. Oh, they're tight. Okay. Yeah, they fit in there nicely at least. Yeah, seems okay. Oh. Okay. And do we need to double up the wire or not? And there's the question. No, I think not actually. Come on. Doesn't want to go in actually. I don't need to replace the fans, it's just I want to replace the fans because they are quite a bit noisy and I don't need the full 2000 watt power. So even if these new fans would be slightly less powerful, I just took a new ferrule and now it fits fine. That's okay. So if you do need the 2000 watt, you might not want to diminish the fan power. Okay, let's see how well crimped on that is. That is good in my book. And now let's see how well it fits in here. It doesn't. Okay. What do you mean? Well, we can actually see what's going on. So we insert it. Why doesn't it bite down on the ferrule? What kind of stupid design is this? Hey there, John Harmon. No, these are fakes. But I would have figured this would have worked. But it's probably the plastic part that's interfering it with not going in far enough. No, I only have fake Wagos and generally they work fine. cut it off, turn the ferrule 180 with the plastic. Yeah, maybe. Okay. I get what you mean. I get what you mean. We can try it by cutting off this plastic piece, or at least trying to. Let's see if we can. In theory, we can. I'm just going to try and mangle this off now. Almost there. Well, this is kind of just okay there. This is to test if it indeed works better without the plastic part. So we got the plastic part off. So now let's insert it. Okay, yeah. Now it's good. Okay, so the plastic part's the problem. I think we'll try that little trick there, Greg. That sounds good. So basically what Greg says is you turn the ferrule around and you insert it the other end. It makes it a lot more difficult though. There. Oh, I guess we need to cut it off before we crimp it? I don't know. Let's do that. Okay. We get a little... Oh no. I squeezed the end. So now the wire won't go in. We'll see. Let's see. I think I have ferrule somewhere without the plastic part, but... Okay, well... We can get a little bit, a part of it at least. So there, that's on. Alright, this needs its own wago. Put your crimps on first, then put the ferrule on... What? Put your crimps on first, then put the ferrule on crimp. I don't understand. Technologia! Exactly. Okay, well this works. So that's good. Put your crimps on first, then put the ferrule on crimp. Or then... what? I don't understand. What I could try is putting it in the crimper. Giving it... No, I can't see it. I can't see it on this side, so that's not going to work. Put the tool on first. Yeah, but I need more words. Cut the yellow part after you crimped it. Yeah, but then the wire is in there. Put your crimps over the wire first. Put the ferrule on the end, then crimp using the... okay. So put... so we have this. But, okay, this fits through here. I have to be really careful. Okay, sure, I think that works. Yeah, okay, that's okay, yeah. Okay, let's try that once more. Well, we need to do it 5 times more. So like that. Yeah, okay, sure, that works. Thank you, Greg and others. Now we need to do the same for this side. Oh, nice. The Quinn LED quad from a few years ago still does the job. Perfect. Okay. It's a bit hard to judge when it's in far enough, but I think I also have some crimps somewhere which don't have the plastic part, but this is quicker than looking for them. Okay, that's one done. Easier would be to put the crimps over the wire first, then insert the ferrule, then what? I don't understand. Easier to put the crimps over the wire first, then insert the ferrule, then crimps. What? I don't... Oh, you mean you can cut it off before you crimp it? Well, sure. But this kind of works, so. We need a PhD for wire crimping. Exactly. Eerst de kabel door de tool, dan... Yeah, okay. Sure, but in this also works fine, I think. So, okay, I think we've crimped everything. Let me do some cleanup. Yeah, I think I understand what you mean now, but yeah. Okay. Good, those make a good connection now. So now we just need to line up the wires. Red to red, black to black. Okay. More like PTSD. No, I have more PTSD about like cables falling out or not making a good connection and stuff like that. That's why I basically wire crimp everything. Let's see here. Okay, so now we have this monstrosity, but in the end we just need these two plugs. And I believe, but maybe somebody can go back into the stream and check. I'll wait. I believe this fan was connected to the most left one and this fan was connected to the most right one. But I'm not 100% sure. So if somebody can go back and check that, I'll wait. But Pepsi, we have Ultra 2000 Pepsi Zero Sugar. So, I mean, we honored your name. Bottom left. Oh, so this one, top right. Okay, so this one is the right, and the bottom is the left. Yes, it's different. It's better. Because we're working on a 2000 watt power supply. So, what was it? Bottom left. Okay, so this one is the left one. Oh, I need my needle nose pliers for that. Let's see, this goes in like that. The top fan on the right, bottom on the left. Okay, so that verifies it. Thank you. I'm just going to use the pliers to get them back in. There. And let's route that cable through here. And then let's first stuff this cable in here. And this connector. And then seal it up with the Wagos. Hold on. This goes down here, and then these go in here. Come on. Okay, there is a CY capacitor down there, so I don't want the cable to go all the way down. Let's do it like that. Let's do it like that. That should be fine. This can't really go anywhere because the capacitor is there. So that's good. I don't know if it makes a difference. I just want to do it the same. So let's plug this guy in. It could be that they're regulated by two different temperature probes. I doubt it, but you know, it could be. So let's stuff the cable in here again. And then the Wagos. Do I want a cable to be there? I don't know. Maybe I want the cable to go over the fan. You can do it. There. That should be good. Nothing's really touching the heatsink a lot. A little bit, but that's like cable, the special cable stuff that can get warm. Okay. Can I still get the top on? Yes. Let's screw in the fans. Quinn Engineering, yes. It's basically stuffing the wire in there. Waiting for fire. I don't think it will catch fire. I do wonder how loud it's going to be. We can still use the low noise adapters the way we did it. But generally with even just the Noctuas at full speed, shouldn't be too bad. Yeah, but the inline Wagos didn't fit, Greg. They were too big. Okay, yeah, that's attached. That's good. Return the old fans. No, no. We know kind of what that sounded like because we could hear it on the stream before, on the previous stream. Those are present. One last screw. Okay, you don't need to tighten those too hard because they're screwing into the bare plastic. They just need to hold on in there, but I think they're not going anywhere. Okay, so this isn't touching the heatsink. There is a little bit over here, but don't think that's going to be a problem really. We'll see. There is a thermal probe in there, so if the heatsink doesn't cool down, it'll just keep cooling, right? I think we're gonna do the wrong thing, and that is replace the hood immediately. Well, if you keep turning them, they will, Felix. So let's see if this still fits. It should. There. That fits fine. You need your 1000 watt to be... Well, are you using 1000 watts or are you using like 500? Because the reason I'm pretty confident I can change these fans is because I'm rarely, if ever, going to use even 50% of the power. No, the previous one were the same size, but it's possible they spun faster, right? So we're going to measure the air output by hand, because that is the perfect measurement. And I think they'll give about the same flow, just they're a lot more efficient, so they make a lot less noise. But we're going to see. What price for the PSU? This was about 130 bucks, something like that. You can check it in the video description, although they're out of stock, but yeah. Liquid cool, yes. It probably doesn't have the fan for nothing, and if they turn on, I don't know, Pepsi. Okay, cool. Let's see here. We need to make a little cable because we're gonna use the load tester, but the load tester already has this cable on it for now. So if I just take one that is similar, I can just let's do that. There. So we can use this cable, which has the banana plugs, and then there. What? Okay, but it is stuck down. Okay, sure. Okay, banana plug. Oh, this one's missing its screw thingy. Yeah, but these are nice. They take like 14 and 12 gauge even. This is 14 gauge that's in there right now. Right, so let's see. Yeah, we don't have the AC measurement yet, but we can use the same setup later to test the AC measurement device. Okay, let me turn this on, see if it explodes. Oh, no, it does not, but it's also not plugged in, so that kind of makes sense. Let me plug it in. There. Okay, seems to still work well. We're at 68 volts. We're slightly above 68 volt. That's interesting. Did we change the potentiometer? No, I don't know. Let's turn on the load. I'm not going to use the software in this case because that's going to be a hassle. Let's set it to, I don't know, 48 volts. And let's go with 8 amps. That should be like, I don't know, 500 watts? No. Oh, we can go to 10 amps. That's 500 watts. 480 watts. There. That should be enough, I think, hopefully, to draw enough load so that it turns on. We'll see. Let's turn the load to 10 amps. There. Wait. What's happening? Oh, okay. No. Okay. Oh, I need to turn this on. That's why the load's not turning on. Okay. Okay, let's hit the on button. On. There it goes. Oh, now we just hear the load. I didn't think about that. Let me take my headphones off. Yeah, no, okay. So before we would hear the load, and then we would hear the power supply above that. Currently the fans are still off, so need to wait a little bit. No smoke. Aww. I think it's still linked in the video description. It's a 600 watt programmable load. They reversed the wires on you. Yeah, maybe. Wouldn't it then just spin backwards? I don't know. Okay, we're gonna just check the fans. Let me move this out of the way. No, okay, they're not spinning. We'll wait. But I mean, this is what I mean. If it can do this passively for this long, it doesn't need much fan. No, we'll just wait for it to heat up a little bit. Hey there, Andrea Bill, watching from Germany. Nice. Ich spreche auch ein bisschen Deutsch. Nicht zu viel, though. And es ist nicht sehr gut. Okay. Oh, maybe the Noctuas do put diodes in there. It's very possible, yeah. Also to prevent the feedback, basically. Oh, Johnny spricht kein Deutsch. Ah. Good enough. Thanks. Ich habe das, wenn ich ein Kind war, von den Fernseher gelernt. Und auf der Schule ein bisschen. Yeah. Anyway. Questioned Quinder, how come the Meanwell HLG series, like I have, doesn't have any fans, It's rated higher compared to some lower end power supplies that do have fans. Passive cooling also has some requirements, and so it might not be able to sustain the load without extra ventilation. And generally they're a bit more expensive. So, oh, you understood everything. Nice. Did you test the fans before connecting them? You were here the whole time. I did not. At some point it needs to like start doing the fan thing. Let's give it more, because we can give it more. So let's allow it to go to 14 amps. And then I need to change it over here. Oh, no. Oh, damn it. I overloaded the tester. Okay, hold on. Let's go back to 12 amps. There, okay. No, I didn't test it. No. This might also be too much, because we noticed during the testing of the testers that 600 watts, they could do it for a while, but not like the whole time. But we'll see. Let's meanwhile measure what voltage the power supply is putting out. DC voltage. Oh, it's at 67.98, and on the tester we're seeing 67.8. So the voltage drop on the cable, this big cable going from the power supply to the desktop. Oh, I think it started. I'm smelling it a little bit. Oh, there we go. They're spinning. Oh, that's so much quieter. But it's also so much little airflow. Or less airflow, I should say. Yeah, the other fans definitely moved more air. But now the question is it going to keep on running, or is it going to shut off? Because if it shuts off again, what am I going to say? Then it's cooling enough to keep up, right? So if it cools it beyond where it needs cooling and turns off again, the fans turn off, then it's fine. For 600 watts at least. I don't know, maybe it's still ramping them up, I don't know. There's definitely less airflow than there was before, but I feel like the giant heatsink is over here. I can definitely feel the warmth coming off of that. Okay, let's give it a little bit of time. No, the original fan direction was this way, so I put them back the same way. It's so much quieter than it was before. But I'm wondering about the airflow, because I can feel the airflow when I'm over here. Yeah, it's sucking it in. But I don't feel a lot coming out of here. It doesn't have anywhere else to go. Well, I can definitely feel over here it's cold, and over here it's warm. So it's definitely pushing out the air from the heatsink. Yeah, I know I can reverse them, but why would I? I'm thinking they put them in that way for a reason. This side really is like cold, and this one's warm. Sure, where's the thermal camera? But linking it up to the PC is going to be a troublesome experience, so I'm not going to do that right now. Let me check. Well, we have our thermistor that's really warm over here, but or the resistor. That's what we had before. Other than that, it's, you know, it's not really warm. Let me check from the other side. Yeah, so there's a hot spot over there. That's where the cables are and the warm exhaust from the heatsink. But the cables are like 33 degrees. And this spot's like 29. So that's not a lot. And then the rest is really... there's not much going on. Yeah, so that resistor over there, we noticed that before too. That's like 71 degrees, but that's basically the same as we measured before. So I'm not too worried about that. Let me look it up. The load tester. We're waiting on this thing anyway. Oh, I need to log in, damn it. Hold on. One moment. This is the load tester. Yeah, I think the blowing in is also better. Oh, my load tester overheated. Well, okay, so let's see. Yeah, I know. Oh, it's on again. Okay, no, don't. Okay. Let's say that was enough, right? So we're drawing no load right now. Can't see my own screen there. Let's see how long it takes for the fans to turn off. They're still running. Oh, now they're off. There. So, when we remove the load, it's like a few seconds before the fans turn off. So, in my opinion, that means that it cooled down enough that it can run passive again. So, although these fans turn a lot slower than the original fans, let's say up to 1,000 watts, this is likely going to be fine. Maybe not up to 2,000 watts, but as I mentioned before, I don't really want to use it up to 2,000 watts anyway. So yeah, for my usage, this is fine, but I can imagine, because the airflow is like a third or even less than the original fans, so those fans were definitely pushing some air. But this is definitely a lot more quiet. So yeah, 99% of the time, this thing... I think it's a constant 12 volt. I don't think it adjusts. But 99% of the time, this thing is on my desk pushing like 10 to 100 watts. Maybe, but more like 10, 20 watts, something like that. So, yeah, you know, I have dedicated power supplies for if I want to test really large loads. Then you could ask, why get this ginormous PSU? Well, I thought it would be cool to look at. And it's still, I think, it'll do easily 1,000 watts. So, yeah. Would that PSU fit the box they sell with the converter? I don't think so. Let me check. So this is the box. I mean, it's already going to be very restrictive with just this fan hole here. This is their PSU in there. This is from a 6012 that I had in there originally. But if we put these side by side, whoa, no, I don't think it's going to fit, because there's not enough room at the front, right? Because this basically goes from the back now here to over here. But if you see here, this is much further back, because the panel still needs to go into the front. Yeah, this one is very badly vented. I mean, it has vents here on the front, right? And here on the bottom and on the sides. But then on the back, it just has this tiny little fan hole without a fan in there. And then the other fan of the power supply is right there, but it's not a great design, in my opinion. Yeah. So that's why I basically also switched to using this bare PSU, and I'll just affix that to the wall or to one of my cabinets or something like that. And then I have this giant 8-gauge cable that, oh sorry, this is 10 gauge. I thought it was 8 gauge. Okay, this is it? No, it's 10 gauge. Okay, I thought it was 8 gauge. It's 10 gauge. I have this 10 gauge cable going from the power supply to my unit over here with an XT60 plug. We built that in a different live stream. And this way I can, you know, this is pretty long, so I can have it pretty far away. I can have the tester like over here. And that way I can keep the noise away and this power supply just out of reach, and it can do its thing over there. And yeah, probably if you're going to use one of the higher wattage ones, you might want to modify that case. I thought it used 8 gauge, but it's 10 gauge. Okay. Well, again, normally this is, you know, we looked at that in the previous live stream about this power supply. It's only going to do a few amps because I'm asking like 5 amps at 5 volt. But that at 68 volt, that's like 0 point whatever amps. So, yeah, doesn't matter. Cool. Well, normally in testing it this week, it stays quiet, or the past 2 weeks actually. It stays quiet. Sometimes it does spin up the fans for like a minute or so to cool down the internals. And that still created a pretty big racket. And now it's just going to do that quietly. Upgrade to 0 gauge. I don't know. I mean, even... Okay, this can output 33 amps at 60 volts. But then we're talking to 2,000 watts. But 10 gauge with 30 amps is still fairly okay. I mean, it's not going to melt. It's silicone wire. It's going to be fine. You get a bit of voltage drop, but then you're down converting anyway, so that's fine. Cool, we're right at 68 volts. Wow. 0 gauge. Well, these are M4 or M5 studs. So on this side it will. On the internal side, though, I don't think it would fit. No. Because those are M3 studs-ish, like. They weren't great. But this is fine. This works great. I've been using it a lot, and it works fine. I just found the fan noise annoying, so I was like, okay, let's get some Noctuas, and, well, that certainly cleared that up. It's not the jet sound it was before. It just might take a little bit longer to cool. That's fine. Okay, so let's get these cables out of the way. Well, actually, let's put them over here, because we're going to build an AC tester with an overlay on the screen. That's the idea. And then we can use the power supply later again to test that. Right? So let me get this off my desk, because it's annoying. There. No, the pots are there to adjust the output voltage. We adjusted that up to 68 volt. And I think it can also do current limiting, but we didn't test that. But for the money, I think it's a nice power supply. I mean, I can't really blame it for the fans it had. Those fans did fine cooling it, so, you know. Yeah, no, I think it's fine. So let's take a look at this tester here. It's from Iotorero, the ESP32C3 version. You need a Quinergy meter for Home Assistant. Well, I can't create everything. And if there's already a good solution out there, like this one, I already have one of these. I actually got it at a Home Assistant event like last year or something. But these are made for ESP Home, and they have an ESP32C3 inside. And the one I have does pretty good. So I was like, okay, I need to solve this. I want AC measurement during a stream crisis. And, well, I thought I'd use this. Or at least try to use this. We have to see if we can get it updating fast enough, but we'll see. So, yeah, we're just going to put this in between. Okay, we need to make a sandwich here. Hold on. So, I normally use this meter. Do we put this one first and then add this meter to it, like so? Or do we do it the other way around? Either way, we're going to be measuring 1 meter's consumption with the other. Maybe I can do it. Oh, I know what to do. If we do it this way, I can subtract in software what this one uses. So I still get the correct readout on here. And in software over here, we can subtract like the watt or 1.5 watt this thing uses. And then we also get the correct readout here. Yes. Okay. Let's do it like that. Good. Yes. Okay. So now we have this sandwich. Let's see if I can still get this in. Oh yeah, that's fine. Okay. Let's turn it on. The plug is blinking, but it's not turning on. Is there like a Wi-Fi mode? Let me check. Yeah, no, but I want to check if there's a... Yeah, see, there's an Atom smart plug thingy now. And a smart life thingy. I don't know about that. Let's hit the Atom smart plug thingy. Sure, connect anyway. Oh, it doesn't have the auto thing. So I got 192.168.4.100. So likely I need to go to like hold on, let me see. HTTP 192.168. What was it again? .4. Okay. .4.1. Oh, okay. Yeah, so I went to 192.168.4.1 using my browser, and now I can see all of my access points. I have lots of access points with the same name. No, I don't think we need the app. So let's connect it to QIoT. I need to remember the password for that. Let me see if this is the password. Hold on. Save. Connecting to network, please wait. Yeah, this is ESP Home. Yeah. Let me check on my router if it joined. Not yet, it seems. Actually, the password for QIoT is probably different. I just never use it. I rarely add devices to it. Let me check. Security. Yeah, okay, I got the password wrong. So let's see if we can connect to it again. Hold on. No, it's probably still trying. Okay, so let's turn it off. No, reading the manual is boring. Okay, turn it off. Let's turn it on again. See if it comes back. Did I wreck it because I filled in the wrong password? Oh no. There's probably something like holding the button resets it if you do it for 10 seconds or something like that. I did try turning it off and on again. I just did. But it's not coming back with its access point when it can't connect. Okay. I'm going to hold the button for 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What do you mean hold the gear? The access point isn't here. Okay, so I held the button for 10 seconds. See if that does anything. Oh, there it is. Oh, okay. That seems to have worked. Good. No, I didn't have this exact issue, but connect, reload, there. Okay, so we're going to connect to QIoT, and now we're going to fill in the right password. Okay. Save. Okay, now I need to check the logs again. Oh, there it goes. Yes, okay. Let me see if we can reach that IP real quick. Yes, it can. Okay. I will show you my screen. One moment, please. Let me see if I can... how do I change the filters? Filters. Effect filters. I want to make it more transparent. Hold on. Color key, I think. Maybe. Opacity. Yes. Okay. No, this is in the way. There. Oh. Okay, so we just joined it to the Wi-Fi. Hold on. Some cable mess here. There. And I can access it with the IP it has on my Wi-Fi now. I don't use MDNS, and I have multiple subnets, and I could set up an MDNS router and multiply or whatever, but I think that's stupid. So we're just going to do it without MDNS again, and probably that means I need to make my own configuration and upload it through the web interface using OTA. I think that's what we're going to do. But yeah. So this is an Atom Plug V3. Okay, cool. Factory reset, restart, safe mode, status LED switch. Let's turn it on, see if that works. Yeah, okay, that works. Nice. Power supply turns on. Can we see some wattage? Yes, 20 watts. Okay, my measurement, my socket meter is saying 10 watts now, but I think this updates pretty slowly right now. Yeah, 12 watts. Okay, so my socket meter is saying 10.2, and this meter is saying 12.2. So the power recorder that I have in between probably uses about 2 watts. It could be right. We'll measure that separately later once we have some faster measurements. If you run ESP Home on Home Assistant, it should pick it up right away. If you have a single subnet, yes, but I have 5 or 6 subnets. So I have like 4 SSIDs, and those all have their own IP ranges, and they can only talk layer 3 with each other, because I don't like all the broadcast spam. And my physical network and my camera network and everything, they're all different subnets. MDNS is not going to work. So anyway, oh, we're now at 11.8. Yeah, okay. We'll play with that later. No, so that's the problem. Let me open up my Home Assistant. We're going to do this in my production Home Assistant, which is always great. But I think that one's the most up to date. Yeah, I can show you this. Okay. We might see some passwords today. I don't know. So if we go here, devices, it's discovered some temperature stuff, blah, blah, blah. But it's not going to discover the plug, because the plug is on 10.10.100. And the Home Assistant server is on 10.10.10 because it's a VM, and there's all kinds of different reasons for that. But they can talk to each other. Your network looks great for a migraine. No, my network looks great for not having issues. Because if you all throw it all into a single subnet, it's going to become one jumbled mess of broadcast and all kinds of shit. And I have really clean wireless because there's no broadcast or crap going on. Everything can talk to each other using layer 3, but it can't spam and broadcast and send all kinds of nasty small packets to my wireless, so my wireless always performs perfectly. Anyway, so let's go to ESP Home then. Add-ons. But it's not going to find it. Okay, I'm on a fairly recent version, so that's good. Yeah, no, this isn't going to find it. Yeah, IoT can't talk to the internet. Maybe it's currently on, off. Often it's turned off, but yeah. Oh, exactly, Philip. That's also a big reason. But for me, I notice a big difference. If everything is on the same subnet, your LAN and your wireless, or if you segregate that, then all the crap that's being broadcast on your wired network, which doesn't really matter on there, is not going to your wireless, where it matters a lot. I can go into the technical details about that, but that's not for this video. So show discovered devices. Yeah, that's not gonna hide discovered device. It's not gonna do anything. That's not gonna work. This is the other Atom plug I have. So yeah, we're not going to be able to integrate this because we could add it in here because we know the IP address. We could add it as an integration. But the thing we noticed last time is even if we do that, we still can't change the ESP home configuration. And we do want to do that because we want to update and things like that. So we're just going to do it the manual way that we know works. So we're going to go for a new device. We don't need that. Oh, we can import new device setup. Anyway, let me find the wiki of Atom or IoTerrero for this plug. Or let's find the web page first. So this is their website. And let's go to products, ESP home. We're already there. And it's not there. Oh, okay, wait. EU plug for ESP home. Oh, C3. Yeah, EU's ESP32 C3. Yeah, this is the one we have. And I got like a 2-pack or something. They're not expensive. They're pretty good. So here they mention the GPIOs and the wrong measurement chip, I believe. So this information is bogus. But let's go to here, because this is supposed to be the YAML. V3. Let me see if this is the new one or the old one, because they had two recently and I had to update it. 25.7. Okay, so this probably is the new version. Let me see. Yeah, so this one is using the ISP IDF. The old one was using the Arduino, and that doesn't work anymore since ESP Home updates and things like that. Yeah, they have the code on there, and they added it to the page now. Maybe because I complained the last time. So let's copy this. Copy raw file. And then let's go to ESP Home. And how did I call this one? Oh, just, okay. Well, okay. Continue. I'm going to empty configuration, and we'll call it Atom Stream Measurer. Yes. Oh no, wait, I can't do minus because it doesn't like that, and I want to do an underscore here. Atom Stream. Oh no, yeah, okay. Stream Measurer. Fine. Okay. Edit. And now we're just gonna say bloop. Paste. Okay. Good. Awesome. In theory, we only need to change stuff at the top. So the name is this. No, wait. Why did they do minus again? I did underscores. Anyway. The friendly name is the same, but then with capitals and spaces. Okay. Device descriptions, fine. The relay restore mode is default on. Let me make this a little bit bigger for you guys. There. I don't really use anything besides Home Assistant, so I don't know anything about Alexa. I only do it with, well, this is not really coding. This is changing a default configuration. We're going to leave it at 10-second updates right now, but we will change that later to see how it does. Current limit 16 amps. The DNS domain is .iot in my case, and it actually, I believe it's this. I need to check in one of my other configurations. Time zone. Oh. No, it's not in a different time zone than the HA server. Oh, it picks up its own time updates, okay. Wi-Fi fast connect. Faster network connection. Oh, sure. Let's set that to true. You can fast connect, that's fine. We want info, that's good. Hide energy sensor. Hides the energy sensor that shows kilowatt hours consumed, but no time period associated with it. Okay. Resets when the device restarts and reflashes. Okay, so they have a different metric that they track. So, like in a year, we can see how much energy I used from that socket. We don't need IPv6. We have a power socket EU, that's correct. And in theory, we don't need to change anything else. But I might disagree with that. Let me check. Blah, blah, blah. Yeah, it's going to do BLE tracker stuff. I don't really need that, but that's okay. MDNS disabled. True. Don't need that. Okay. That's fine. BLE tracker stuff. UART. So it talks to the internal power measurement chip over UART. So let's leave that. And then they do all kinds of stuff over here. We're going to leave that for now. That's probably going to be fine. Oh, I have an error somewhere. Where is it? Oh, it doesn't like my DNS domain. Okay. Oh, right. You need to have a dot in front of it, I think. No, it still doesn't like it. What do you mean? Let me check in my other devices. So let me check in here, for instance. Yeah, .quindorian.iot. Copy. So let's try and fix that. You can copy with the right click, but you can't paste. It sucks so much. It doesn't like it. I don't know why. Wi-Fi fast connect. Oh, maybe it doesn't like my fast connect change. Okay, so let's set fast connect to false. Fast connect false. Oh, okay. It didn't like my fast connect change. But I don't know what it then expects instead of true or false. Generally is the opposite, so... Anyway, let's save this. Install. Let's do a manual download because we want to flash it using the web interface. Manual download. Uh-oh. For some reason it turned off the relay. I don't know why. In this case it doesn't matter, but... Okay, we'll download this in the factory or... Oh, in the OTA format. I guess we want to use the OTA format. But we also have ESP Home Web. We'll try the ESP Home Web format first. So now we go back to the web interface. we say choose file. We'll use that one we just created. Update. Let's see what happens. Well, I don't know. Well, I don't know. We'll see. I got the wrong one then. Update failed. Okay. I think Philip's right. Download OTA format. Keep. Okay. Choose. The other one. Update. All kinds of stuff going wrong here. Seems to be updating, that's good. Update successful! Nice! Do I wait? I'm not gonna wait. I'm just gonna remove this. There. Okay. Oh, now it's also the Atom Stream Measurer. Atom blah blah blah. Okay, good. The time is like completely wrong. Is it? Yeah, it's wrong. It's 1 hour off. Okay, well, I generally have it draw the time from Home Assistant. I'll fix that later, I guess. Okay, so now we have to add it to Home Assistant. So I need this IP. Let's see. Settings. Devices. Oh, it's kind of cut off, but add. We're adding an ESP home device. This is the host. No. There. Okay, Atom Stream Measurer Blot, skip and finish. Ah, there we go. It's firmware 2.0.1. That's basically the script we downloaded earlier. Power state, always off. Always on. Okay. Let's turn the switch on. Okay, that worked. For some reason the fans are on. For the power supply. Okay, Wi-Fi signal seems okay. Total daily energy, total energy. Cool, we can track the total energy. Yeah, we will. So now we have this working, and we can visit the webpage from here, but I also think we can go to, no, this is not the ESP home. Can we get to the ESP home configuration? I don't think so. No. Okay, let's open that in a new tab, duplicate. Settings, add-ons, ESP home. I wish we could get to the configuration just from that tab. Anyway. Let's go here, and currently the sensor update interval is 10 seconds. Let's go to 1 second. Hey there, Dave Menkehorst. We're testing an IO Torero smart plug with an ESP32C3 in there with ESP Home. And we're going to try and make some kind of nice overlay in Home Assistant somehow. So sensor update interval, we're going to go from 10 seconds to 1 second. Let's go. Install wirelessly. That should, in theory, now work. Oh, it doesn't. Oh, right. It doesn't know the IP address. Because I don't have this DNS name. So I need to do some magic in my router real quick, because I don't use MDNS and blah blah blah. I need to look up the IP address. DHCP server leases. It's 26, right? Yeah, 126. Oh wait, where's the other one at? Oh, that's 27. Okay, yeah. Well, I set my leases to 60 days, so we'll just keep it at that. That's why I have different so the IoT network, if I give a DHCP address to something, it gets to keep that lease for 60 days. While on my normal network or my wireless network, there are different values there. So I just need to add a static DNS entry. I copied the name. So no, wait, I didn't copy the name. Copy. This is 10.10.126. Okay, so now let me see if I can ping it on my computer. Run CMD ping. Yes, I can ping it. Very good. So DNS resolving now works. I know this all seems kind of cumbersome, but in my opinion, this is the proper way to do it. Yeah. Okay, let's see. Probably now this isn't going to work because it tried to resolve the DNS and it couldn't find it. So, yeah, it's not going to retry it. I need to clear the cache somehow, but I don't know how. And the only way I know how is by rebooting the Home Assistant virtual machine. I really wish they'd make a better method for that. Because I don't think we can do it in here. System... repairs? No. Network? I want a flush DNS option. I know that works. I know, but that, you know, I don't have the DNS server for nothing. I just wish I could somehow flush the DNS. We can try updating ESP Home. Let's see if that works. Update. I don't think so, but... Okay, configuration. Maybe there's something here. No. I use ping for status updates. That's right. Okay, open. Update wirelessly. Yeah, I can restart the whole Home Assistant, but it's kind of stupid. Nope. Damn it. Exactly, Philip. Yeah, yeah. I just wish there were developer tools, maybe? No. I just wish there was an easy way to flush the DNS. Because the quick reload... Oh, wait, advanced? Yeah, no. Okay, we'll reboot the Home Assistant VM. Gonna take a minute. The lights might flicker. Rebooting system. Sure, but I mean, they already got people bothering them day in, day out of features they want, so... I've tried that, Felix, but even that often doesn't work. Connection lost. Reconnecting. Oh no. It's not sitting in the whole way. Okay. Yeah, I've tried those things, Felix, but I never got a good way of getting it to work. Okay, it's almost there. So let's see if we can go to add-on here, open web UI, install wirelessly. There. Amazing, now it works. Oh, I don't know, Philip. That's just the way I'm used to doing it. Wow, the Project China Atom Technology Smart Plug V3. What? It's a revision 0.4 ESP32C3. What? What do you mean? Okay. Anyway. Okay, the relay's on. That's good. Can I turn it off? Yeah. So now it should be measuring every second. Let's see. And it's updating faster. That's pretty good. Yeah, sure, Alex, but there should just be a button in the interface. I can't be the only one running into this, but it's okay. Cool. Okay, so we can see our real-time measurement here. Apparent power. Okay, current. The power factor. Oh, okay. My meter says 0.320, and this one says 0.39. That's pretty close. So let's disconnect the power supply and see how much my meter itself uses. Can we see that? Yeah, that's what I was afraid of. Those measurement plugs, the Wi-Fi measurement plug, it doesn't show any power usage under 3 watts. So, yeah, under 3 watts we can't use it. That's why I also have the other plugin still in there. So we can't really determine how much power it uses. It's a bit hard to say. I think it's about 2 watts. But, you know, when testing power supplies, that's close enough. And I can just see the idle wattage on my own meter. So that's not too big of a problem. Yeah, this is pretty okay. Maybe let's see if we can make it faster. Can we do 0.25 seconds? We're probably gonna break it. I don't know. Well, let's see. It's gonna spam a lot over the Wi-Fi. Okay. Can we still connect? Yeah? Okay. Yeah, that's faster. It's a bit all over the place. Power factor unknown. Okay. Let me see what this is doing to my Wi-Fi network. Interfaces. Let's see. IoT backyard. I think it's this one. Yeah, we're getting about 4 to 5 kilobytes a second RX and TX the whole time. I don't know about that. Well, we'll see. Let's give it some power. So let's connect the wires again. We're still at 48 volt and 14 amps. We're just going to leave that. But we're going to scale down this guy. What? Where am I? Five amps. Go. Oh wait, I need to turn this on. Is it working? Yeah, it's working. Okay, you can see the wattage here. Oh yeah, we can see it change. Okay, so it's saying 270.7 or whatever, and my other meter is saying 278.2. And the power factor is 0.6, and my other meter is saying 0.597. So that is pretty close. There's a few watts difference though. Reactive power, okay. Apparent power, current 2 amps. Yeah, 2.08 I see on my other meter. So I can now change the voltage. So let's say I'm going to 12 volt. That will change the power usage drastically. Yeah. Now both are saying, so now my meter is saying, sorry. My meter is saying 85.5. And, well, we're seeing about 85 on there too. So that's pretty good. But I guess it depends on, let's go to 24 volts. I believe the chip that's in here is like pre-calibrated, but we can check the ESP home configuration. So now we're seeing 150.9 on my other meter. and 147 in here. Okay, 36, 214 and 208, 209. So the higher it goes, the more it's starting to deviate. So let's go to 48. 276 and 269. So that's almost 7-8 watts difference. Okay, let's up this. I'm gonna wait for it. Okay, so now we're seeing 430 on the wall and 418 on the measurement plug. Okay, I can go up a bit more. Oh, now all the fans are turning on. Yeah, okay. So now I'm seeing 438.9, 0.6, 0.7, whatever on the wall, and 420. Wow, 423. That's a big difference, though. So I'm seeing 539.7. Oh. On the wall, it's fairly consistent, and I'm seeing 522. I don't know, 0.5. That's a 17.2 watt difference. Later, John. Okay, so let's flash it back to 1 second. Let's turn this off. And see if that improves things. Because this is like 20 watts off. I'm afraid it won't. If we look in the configuration, we can see if there's more calibration we can do. Let's see over here. The CSE 7766. Yeah, so it's saying it needs at least 3 watts. Yeah, I don't think we can do any configuration here. Throttle average. Sensor update interval. Okay. Anyway, let's flash it to 1 second. Hey there, homies. Yeah, we're still playing with the energy meter.
Very much alike.
I guess you're full. I'll need to look into that. I trust my Digital power meter a bit more than this Wi-Fi one. So, okay, we're back. Good. Let's enable the output, and let's test it again. So let's wait for it to stabilize. No, I'm seeing 537.38 on the wall, and this is measuring 521. So, for let's say 520, there's 16 to 17 watts that are missing. The power factor is almost the same. The current it's measuring is a bit low. Yeah, I was afraid of that. We did the ESP home part over here. So I can see and calibrate it more to what my own meter says. And I can, you know, simulate various loads that I can then run through this power measurement device to see what the other one that it's plugged into should say. To get it closer, I guess. Yeah, all the fans are going again. Because like I said, I trust my my Zahudi tech a lot more. That's been, as far as I've been able to tell with other meters too and such, it's been spot on. So yeah, I was hoping that this one would be good because the measured error of active power is about 0.2%. Effective current and effective voltage. So active power 0.2. If we have 539 times 0.2. No, wait, 0.2. No, okay, sorry. 539 times 0.00. Wait, what? I need to think. Okay, 0.002. Yeah. Oh, okay. So it should be off about 10 watts, but it's already off more. Yeah, no, 0.2% should be about 10.7 watts, but as we can see here, it's showing 522 and the wall's showing 538, so that's more than 10, right? But if we go down to 12 volts over here, the load drops a lot, so now we're only drawing like 119 watts. So on the wall it says 158, and on here it now says 140 something. 45. 154 versus 158. So now it's only 4 watts difference. So it seems the more power we draw, the higher the difference becomes. Yeah, and if it measures it by using the current is 0.5% off. But then the current isn't that high. So even with 3 amps of current, we should see only 0.06 amps difference times 230. Yeah, okay, that's 13.8 watts. You don't trust either of my power meters. What do you mean? My power meters are great. No, I trust the Zohiri tech the most. Yo. So I'll need to see if I can calibrate this a bit. Yeah, I don't like Tuya. I don't use anything Tuya. I mean, it's working. And we can create some kind of nice Home Assistant card that should show us some cool values. At least it can update fast enough. But yeah, if it's not like if it's gonna like be 20 watts off at 600 watts, that's not great. The best full home monitoring for United States? No clue. Well, you know, you can get a good meter. The Tech, they're known to be really good, so. So this is cool, but I need to see if I can do some calibration. Yeah. I guess I can do several measurement points with my load testers, like 100, 300, 600, 900, and 1200 watts, and then see if we can calibrate that. Because if we can calibrate that, then it's likely going to be pretty close. It'll be cool to see in a year how much total energy we burned in the lab. Let me check, hold on. I need to find the right article here. There's one from Frank. Let's see if the CSE power sensor. Okay, so they have an article on this power sensor. Okay. So I guess it's a sensor filter. Okay, yeah, so we can use filters. And then we can calibrate linear. Okay. Oh yeah, there's lots of fans going right now. Hold on. Let me turn off the tester. There. Now it's a lot more quiet. Wow, calibrate polynomial filter. Quadratic polynomials. I don't know about that. Exponential moving average filter. Okay. Heartbeat filter. Wow, you can do lots of filtering. Okay. We should probably start with the calibrate linear. Yeah, but then I don't know what value it's actually seeing, right? So if we look in here, the CSE lambda if return 0.06. Return 00. So 0.06 is 3 watts, it seems. Okay. Oh, wow. If above current limit, turn off relay. That's cool. Okay. So it already filters. Throttle average. So it averages based on the sensor interval. Okay. But then I need to know the raw values it gets instead of the... Because this value somehow gets converted. Oh, this is current. Yeah, okay, so it measures the current. And then the watts, apparent power, reactive power, power factor. So what are we looking at here? Our power. Yeah, I get it. So where does it show power factor, reactive power, apparent power, energy, okay, power. So power is this one, yeah, so that's the one we need. Oh, okay, so this one says if lower than 3, that would mean that this just does the normal numbers. Okay, let's give it a quick go and then I think we're going to call it. So this is already under filters. Yeah, so I can just copy this part. Hold on. Okay. I don't know what this last squares means. Can we just do calibrate linear? We don't need the last squares. Oh, okay. Method. Okay, default last squares. So we don't need last squares. Okay, so we don't need this. Data points. 0.0 is fine. Let's say 0.0, 0.0. But I guess I should give it 100 watt load. Or how do we do this? We do a 100 watt load on the Tech, and then we see what it says in here, and then we change it. So we don't flash right now. We enable we enable this guy, and we're just going to change the voltage until I see 100 watt on the Tech, and then I need to see what it says. So okay, a little bit more. Okay, now it says 100 watts, and this one says 98.7. So then I should say 98.7 should be 100.0. I think that's correct. So let's do a few. Let's see if it's still saying 98.6. Well, okay, 98.6. Well, no, let's keep it at, okay. So now we go to 200 watt. Okay, overshot. Yeah, okay, 199.9, that's fine. We're gonna say this is 200, and it's currently measuring 194.9. Oh wait, no, 194.95. I'm gonna give it a 194.8. No, wait, 198.19, sorry. Yeah, 198.4. Okay. And this will be 300. So we're going to up the voltage again. Okay, a little bit less. This is actually an easy way to do it because I just changed the voltage on here. Okay, now we're at 300. And this one is saying 291. Yeah, it's still fluctuating. I'm going to say 291.8. 291.8. Okay, let's do a 400 then. And I can do more later. So I need to go to 400. Oh wait, that's going to take a while. Yeah. Almost. Yeah, okay, got it. Well, 400.2. Eh. Okay. 388 point. .5. I don't know. Okay. Okay, sorry. We'll do one more. 500. We'll also do 500 watts. Then we have the most things I can easily test. Let's go. Oh, overshot. Yeah, okay, fine tune it. Okay, 500. That is 484 point. Yeah, 484.6. 484.6. Okay, let's flash it. Oh no, it's saying that configuration is wrong. Why? Oh, it'll tell me when I try to flash it. Error 267. Okay. Okay. Well, there. No. No. I never understand. Okay, now it's fine. Okay. These spaces in this stupid YAML file, I never get it. Okay, let's lower the voltage a bit. It's getting warm here. Let's go to 12 volt. There. Okay, let's see what's going on. Oh, that's a bit. I'm seeing 157.4 on the wall, and well, the software is pretty close. That's not bad. Okay, VSET 24. Go. Later in Digital.Tech, I'm seeing 284.6 on the wall, 284.4. That's acceptable, that's fine. We don't measure like point whatever watts generally. Okay, let's go to 36. 411.7 on the wall, 411 point... close enough. Okay, let's go to 48. 538. 538. Hey there, Johnny. So, but the problem now is, do I need to do the I need to do the same for the current? Because this now is still way off. And that means this is off, and this is off, and this is probably off. Okay, it's not perfect yet. It's drifting a bit. We're at 539 on the meter, and 538 point something on the Wi-Fi meter. So, still needs a little bit of correction, but that's pretty good. Hey, and the best thing is, we've now calibrated it with the Zuri tech in there, so that's already offset. Yeah, okay, so this is now differing like half a watt. I guess we could easily adjust that by... so, yeah. Because I have no points above 500. Yeah, probably. Well, I have two testers, so I could test it up to like 1200 watts. And then it should be fairly accurate over the whole range, and I can always adjust it slightly. Yeah, that's pretty good. Okay, that makes me happy. Because now, I mean, I don't care if it's off like half a watt or a watt. That's fine. So I'm seeing like 538 on the wall. This is saying 537.5. That's okay. I mean, at that many watts, we don't care, right? So maybe I should also do some lower points. Because if we go to like, I don't know, let's go to 5 volts. We're doing 82 here. Oh no, okay. 82.14 and 82 point... Yeah, about the same. That's fine. Okay. Let's go to 4 volts. I don't know. 68.5. 68.5. That's pretty good. Yeah. Okay, so I need to add some more points up to say 1000 watts, then we generally should have the range we need. And I probably also need to do it for the current. And other than that, I think everything else is calculated from that. Maybe the energy isn't. No. And the apparent power, reactive power. Jesus. I really don't feel like calibrating all of that. Let's calibrate the... I'll calibrate the current at some point and the power. Other than that, well, maybe I can calibrate the voltage, but 2 to 4.2, 2 to 2 points. No, I mean it's not meant as like a lab instrument. It's just for on live streams where I can have an overlay with a number, so I don't have to shout it out the whole time. But it needs to be accurate in like 1, maybe 2 watts at least, not like 20 watts off. That's stupid, right? But I think it'll get there. 68.31. 68.3, yeah. The power factor is now off. My meter is saying 0.98, and this is saying 0.52. So, yeah. Maybe if we correct the amps, but I don't know. I don't really know how I can measure the voltage, because I can't change that. Cool. Okay. Yeah, let's kill this. So, mission successful today. We have changed the fan, so now this guy is a lot quieter. It also cools less, but that's not really a problem for our use case. And we've integrated a Wi-Fi ESP home connected power measurement device, which we still need to calibrate better. But then we'll be able to make a nice dashboard and have some sort of overlay on the screen, which updates like once a second or something like that, but that's fine. I don't mind that. Wow, low wattage is also fine. Saying like 10.2 and this is saying 10.23. Pretty good, pretty good. Well, I won't bore you with that calibration. I'll do that myself sometime. Yeah. Oh, we need a secret, don't we? Maybe if I look in the ESP home configuration, they seem to be generated from the measurement. So I think the device itself is giving off apparent power. So you'd have to calibrate everything separately. Yeah, well, I can calibrate the voltage somewhat, like with a high load and a low load. But other than that, I can't do too much over there. But I think this is all coming from the device directly. So, light component? No. Yeah, the CSE power sensor. See, this all comes from the sensor itself. So I'd have to calibrate all of that differently. Yeah, well, anyway. Oh wait, secret time. Yes. So I've been working on stuff upcoming for this year. We can disable this. And one of those things is this. This will be a very nice upgrade. So currently we have the AB, the AE and the ABE ESP32 modules. And those models will stay for the Dig Uno and Dig Quad. But this is a revised ABE, which is now one board. So no longer are we using the stacked board. This is actually a 6-layer board with one of the newest ESP32s on there. So this is also the same one as in the Dig Next, with 8 megabytes of flash and 2 megabytes of PS RAM. It now uses an external clock crystal with timing delay circuit during boot and blah blah blah. I've basically redesigned the whole ESP32 board in the way I like it to work, not so much a copy of what's out there. There's a built-in microphone on there. And there's no diodes on there, although it has multiple inputs. So instead of diodes, it now uses load switches. You can see one over there, for instance, and there's one over here to switch between the 5-volt in pin or USB, because it still has USB and it still has a USB to serial chip on there. It has loads of capacitors. ESD protection, some LEDs and blah, lots of stuff. One other thing it does different than most ESP32 boards out there, instead of an LDO to go from 5 volt to 3.3 volt, it actually has a tiny buck converter on there. So it generates a really stable, high quality 3.3 volts. Yeah, lots of improvements. So external crystal, so you can run Bluetooth and Wi-Fi and Ethernet at the same time, while still also having a microphone on there and the Ethernet. Yeah. So basically, this is a new generation of the ESP32 Queen LED boards. much more my own design even than the old ones were. There's also ESD protection on the 5 volt side. On the 3.3 volt side, there's over voltage protection on there. Yeah, I'm hoping these will be very robust, basically. Let me see if it works. Well, I know it works. But yeah. So the way this is constructed now, it was actually pretty difficult to make this a sandwich, because the pins you see here are from the Ethernet socket, but then there's also an ESP module on here and the USB-C socket, but the USB-C socket is basically like integrated into the RJ45 socket. And well, this was kind of a puzzle challenge to get right, because even though I used 6 layers, because otherwise it just wouldn't fit, you still have to make it mechanically fit, right? These pins can't go under here, but the USB socket can't go here either, or here. So it was a challenge, like these pins, and it was a challenge to make it fit in the same form factor. But I think I got there. Yeah. So the LED, I've already dimmed that down, so you can see here that there's a 5 volt pin there and a 5 volt USB. These will light up depending on what is providing the power. This is for the 3.3 volt. There is a LED for Q1 on there, but I don't think the firmware currently activates that. It's just a minor thing. Yeah, audio programming, etc., etc. So yeah, that was a bit of a challenge. And of course, there's also going to be updated versions of the normal version. So this is the one without Ethernet for on the Quinn LED boards. Yeah. This is a regular ESP32, but with 8 megabytes of RAM, flash, and 2 megabytes of PSRAM. So let's see this one. Yeah, so this one activates the Q1 LED. Yeah, you can reset it. Oh wait, this is one where reset's still broken, I think. Yeah. Yeah, so I don't know which prototype I need to get. There's another one here where I already fixed the LEDs. So the production versions won't have that bright LED. Now this is also still way too bright. Yeah. So the resets on here don't work. I already fixed that in a newer revision. Because if you look on this one, well, I can't show you because then none of the lights turn off. Anyway, that's all been fixed. It takes a few iterations. Yes, these are very, very nice. They're basically the same size as the old boards. There's just a lot more stuff on there. Yeah. So at some point in this year, we'll be upgrading the Dig Uno and Dig Quad lineup to these. That basically also means that each board will have a microphone on there automatically, and more memory, more flash. In general, just a better board with like buck converters and protections on there, etc. Add PoE. You add PoE. Where would I put it? I mean, there's literally no room here, like none. There's absolutely no room to put anything anywhere. And then over here, you'd say, oh, well, you have free space here. Well, I need to run tracks somewhere. There's no space. I mean, even just the transformer you need for it, there's no space. Well, this one will come with external antenna or onboard antenna. 12 layers. Yeah, so, but that at some point it doesn't matter because you need to have vias then to go to all these layers. But you can't space 2 vias on top of each other because then you have to go to buried vias that go from like layer 1 to layer 4, but not from 4 to 6, 8, 12, whatever. do you mind paying $40 for one of these? So yeah, that's not viable, I think. Maybe a little bit, Rich Jagger. It also depends on which software you're running. Like in Moonlight, you might be able to get more in WLED Moon modules because it uses the PSRAM more and stuff like that. So it depends on the software. Yeah, so like Philip asked, the external antenna version is the same as this one. It just has the different module on there. I don't think I have one on my desk right now, but it's basically the same thing. Yeah, so but that will come together with new, or not new, updated Dig Uno and Dig Quad boards, but when, I don't know yet. I've absolutely been working on it the past few months, so we're getting pretty close. So that's going to bring some nice improvements, especially also the 8 megabytes of flash. At some point, the projects are going to need more than 4 megabytes. And then you'll already have an ESP that does that. So yeah. But yeah, this one's an interesting sandwich. The diff power, yeah, no, I've been working on diff power too. I've been working on lots of stuff. So don't worry. Maybe there's a newer version of a Dig Uno here with one of those on there. Maybe. You just came in time for the secret. Exactly, Fox and Air. Well, let me see if anyone's still here. I don't know. Wait. Oh no, I clicked it away. This one? Yeah. Oh, we still have 59 people. Nice. No, the Dig Uno and Dig Quad are 100% the exact same size. But they some improvements. There have been changes and improvements. No, okay, we'll get into it. We'll get into it quickly. As you can see, I'm using the new fuse type. The I/O pins on the side are now one line again, so they're easier to plug in. We got some complaints about that, although it was partially on purpose. There's a completely new DC circuit on here. It's still 5 volt to 24 volt, but we've been having some 24 volt issues, so this should solve that. There's now an I2C port here. That's new. And yeah. No. This is the exact same size as the Dig Uno before it. Maybe you can see better from over here. So all the cases and things like that will still work exactly the same. Maybe, well, it won't have this port, but you can make a cutout for that or not use it. I don't know. Right. Quad, same thing. Okay, for showing stuff. I'm showing all the secrets. The Quad is also getting a redesign. There is already an updated version for this one. So also new DC circuits. We're getting some new switches which will be on 33R by default. The new type fuses, some extra protections in there didn't have before. It'll be pin compatible. Yep, no problem. So you can use an old ESP on here or a new one, and the new ESP can go on the old boards too, if you want to, etc. No, there's been some melting and testing, and is this one with a blown converter? I don't know. You know, these are testing boards. I'm testing with them. Just better circuits, better features, or improved really. It'll still be about 30 amps. The red screw hole? What? Oh, that's where that went. Okay, I was already wondering. I found it on my desk, but I didn't know where it was from. But okay, yeah, yeah. It doesn't matter. These are testing boards. They get abused like all the way. The Day of Secrets. Yes. Well, I've been working on this for months, and I didn't want to share it yet, but now it's time, I think. So. Cool. Well, we accomplished all our goals today, and I think it's a great success. The power supply is still on, but yeah. Type of fuses though, those are the same fuses that the Power 5 HV uses, or the new Dig Next, or the Dig to Analog Plus, and later on also the Dig Uno and Dig Quad. But you can get them from Allnet. They have them in little baggies now. But I also have an article where you can order them on AliExpress, for instance, stuff like that. They're pretty cheap. I can't do everything on stream, Foxioneer. I'd have to stream every day. No problem there. I test things. Thanks for being here. Sure. Well, I'm going to call it a day. Thank you all for being here. Next week, I don't know what I'm doing yet. Might be a video, might be a live stream. Not sure. And otherwise, catch you there or on the Discord server. Thanks for watching, guys. Bye-bye.